Hi all, welcome to new class. Today's class is the problems related to generators, that is DC generators. So in the previous class we have discussed about the types of DC generators. So today's class is about the problems related to the DC generators. Let's let us go through the problems. The armature of a 12-pole DC shunt generator has 50 slots and is wave wound with 12 conductors per slot. The generator is running at a speed of 625 rpm and supplied a resistive load of 15 ohm at a terminal voltage of 300 volt. The armature resistance is 0.5 ohm and field resistance is 60 ohm. Find the armature current, the generated EMF and the flux per pole. So it is given that it is a shunt generator and the given data are number of poles is 12, then it has 50 slot and is wave wound. So in the case of wave wound generator, the number of parallel path A is equal to 2 with 12 conductors per slot. So the number of conductors is 50 slot into 12 and that is equal to 600. Then the next data given is the generator is running at a speed of 625 rpm, that is speed is 625 rpm. Then resistive load of 15 ohm, that is and at a terminal voltage of 300 volt. So the load resistance RL is given that 15 ohm and terminal voltage V is given as 300 volt. Then armature resistance is 0.5 ohm and field resistance. So this is shunt generator. So here it is RSH and RSH is 60 ohm. Then we have to find armature current, generated EMF and the flux per pole. So before that we have to draw the diagram of this shunt generator, then only we can do the problems very easily. So first of all draw the shunt generator. So this is the diagram of shunt generator. The first question is to find the armature current. So this is armature current and IA is equal to ISH plus IL. So we have to find ISH and IL, and here from here we can find ISH, that is ISH is V divided by RSH, that is the field current ISH is equal to terminal voltage V divided by RSH and V is given that 300 divided by RSH is 60. So we get 5 ampere. Then we have to find IL, that is load current. IL is equal to V divided by RL. RL is given that 15 ohm. So V divided by RL and that is equal to 300 divided by 15 and we get it as 20 ampere. Now we can find the armature current, that is first question, armature current IA is equal to ISH plus IL and that is equal to 20 plus 5 equal to 25 amperes. Next question is to find the generated EMF and flux per pole. So to find the generated EMF, the generated voltage EG is equal to V plus IARA, that is the terminal voltage V plus the drop in the armature resistance, and that is equal to 300 plus 25 into 0.5, and that is equal to 312.5 volt. Next we have to find the flux per pole. So to find the flux per pole, we have to use the equation Eg is equal to 5ZNP divided by 60 into A. So here all the data are given except this flux. So to find the flux, phi is equal to Eg into 60 into A divided by Z into N into P. Eg is 312.5 into 60 into A is 2 and divided by Z is 600 into N is 625 into P is 12, and we get 0.00833 Weber, and we can write it as 8.33 milli Weber. Next question is, a 4-pole long shunt DC compound generator supplies 100 ampere at a terminal voltage of 500 volt. If the armature resistance is 0.02 ohm, then series field resistance is 0.04 ohm and shunt field resistance is 100 ohm. Find the generated EMF. Brush drop per brush is equal to 1 volt. If the machine is connected short shunt, find the generated EMF. So this is the case for long shunt and short shunt compound generator. So the given data are number of poles equal to 4. Then the compound generator supplies 100 ampere at a terminal voltage of 500 volt. So the terminal voltage V is equal to 500 volt and 100 ampere, that is IL is equal to 100. Then armature resistance, that is RA, is equal to 0.02 ohm and series field resistance RSE is equal to 0.04 ohm and shunt field resistance RSH is equal to 100 ohm. Then brush drop is given as 1 volt per brush. So we have to find the generated EMF in the case of long shunt and short shunt compound generator. So for that, first of all, draw the diagram of long shunt generator. So consider the first case, that is long shunt generator. So this is the diagram for the long shunt generator, and here we have to find the generated EMF. So here the generated EMF Eg is equal to V plus the drop in the generator plus the drop in the series field. So Eg is equal to V plus IARA plus IA into RSC plus we have to consider the brush drop, that is brush drop, and it is given that 1 volt for the brush, each brush. So we have to write it as 2 volt because there are 2 brushes, and here we know V, then IA we have to find, RA is given, RC is given, so we have to find IA. So to find IA is equal to ISH plus IL, and here IL is given as 100 ampere. So IL is given as 100 ampere and ISH we have to find. And how will you find the ISH? So here this terminal voltage is across the shunt field resistance. So V is equal to ISH RSH. So from this we can find ISH, that is V divided by RSH. V is 500 volt divided by RSH is 100 ohm. So we get 5 amperes. Now we can find IA, and IA is equal to ISH plus IL. ISH is 5, then plus IL is 100, then we get 105 amperes. Now we can find EG. So EG is equal to the generated EMF. EG is equal to V 500, then plus, here this IA we can take common. So IA is 105 into RA is 0.02, then plus RC is 0.04, then plus brush drop. So brush drop is 2 volt because 1 volt per brush. So there are 2 brushes. So we have to write 2, and we get it as 508.3 volt. So this is the case for long shunt generator. Now we have to draw the diagram for the short shunt. So this is the diagram for the short shunt generator. Short shunt. So here to find the generated EMF EG, EG is given as, here it is given as the voltage drop in the armature plus the voltage drop in the series resistance, series field resistance, then the terminal voltage, that is V plus, this is IA into RA, then plus, here this is IL, so IL into RSE, then plus brush drop. So here we have to find IA. So IA is equal to ISH plus IL, and here ISH, we have to find ISH. For that, here the drop across, that is the voltage across this shunt field is terminal voltage plus the resistance, that is series resistance. So we can write as, that is ISH. ISH is equal to V plus, that is V plus ISC into, the ISC is same as IL, so IL into RSE, then divided by RSH, and here V is 500, then 500 plus IL is given as 100 into RSE is given as 0.04, then divided by RSH is 100, and we get ISH as 5.04 amperes. Now we can find IA. So IA is equal to ISH plus IL, and ISH is 5.04 plus IL is 100, and that is equal to 105.04 amperes. Now we can find the generated EMF EG is equal to, V is given as 500, then plus IA is 105.04 into RA is given as 0.02 plus IL is 100 into IL into RSC. RSC is 0.04, then plus 2, and we get it as 508.1 volt. So this is the case for long shunt and short shunt generators. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.